All right, to be respectful of your time, we're going to go ahead and get started as people may continue to filter in, but thank you for joining us for a Swagelok presentation of analytical instrumentation by Brian Applin. He's a field engineer with Swagelok. Brian began his career with Swagelok at Columbia Fluid System Technologies as an intern in 2009. He was supporting the South Carolina University campus until 2012. In 2013, Brian joined Swagelok, South Carolina as a custom solutions engineer, supporting the sales team and providing drawings and quotes for custom solutions applications. Brian joined the field engineering team as a regional field engineer at the beginning of 2016, and he is an analytical instrumentation expert. Brian enjoys golfing and Zymergy, you can ask him about that later, and going to concerts with his wife and friends. And I'll turn it over to Brian. And if you guys have questions along the way, use either the chat or Q&A feature, and I'll help him monitor that. So thanks for joining.
Ben. Thanks a bunch, Ben. Hey, Zymergy does involve sampling, so you are right. I'm definitely an analytical expert in that as well. So yeah, shoot me a message and we can talk. But yeah, we're going to talk about analytical instrumentation today. I want to spend just a little bit of time kind of setting a baseline. We'll go over a little bit of our capabilities and talk a little bit about Ben and I's role as field engineers. Then we'll get into the analytical systems. We'll talk about the differences between online and grab sampling systems. Just going to differentiate between the two so that you understand a little bit of the language of what I'm talking about. Then we'll go through some basic rules of either online or grab sampling systems. We'll just talk about sampling best practices in general, and then I'll show you some typical arrangements for our grab sampling panels. Show you some accessories and some features of them, and then we'll get into questions. Obviously, please ask questions throughout. We can definitely direct answers as we go through the presentation. So again, it's just starting off. I just wanted to touch a little bit on our capabilities and drive into why and how we really support analytical instrumentation. So you're probably really familiar with our ability to offer education services around fitting installation or tube bending, things like that. Maybe even have taken a process analyzer sampling system course before through us. You may have even utilized our services as far as custom solutions, so we can obviously build your systems for you and set them up so that they're kind of a plug and play application from really small assemblies all the way up through panel builds. But we really are leveraging the advising and design portion of our capabilities in the analytical field here. We're really trying to help troubleshoot and advise and help support some best practices in sampling when we're looking at these systems. We can also help design these systems, and we'll get into a little bit of that as we talk about it. But some calculations about flow and time delay and things like that we certainly help out with. So just building upon that field engineer role, Ben and I are here for just a really high level of technical expertise. We can help troubleshoot your systems and understand, or help to understand what's going on when a regulator's not acting right, or we're having trouble with valves, or just selecting product in general. And then we can really build upon that and try to recognize and bring in some design best practices and adherences to codes and things like that. So to do a lot of that advising service, we use an application on a tablet to really capture a lot of that data. This helps us to really quickly collect the data and then deliver a report out to you. Try to make it really automated and kind of user friendly. And so the application looks like this. There's a little bit of an interface, and we type a lot of things up, take photos of what's going on in the system, and then the report looks like the one shown here on the right, where we've got captured data, we've got pictures, we've got geolocations, things like that to help show what's going on with the system and help advise you there. Again, we're looking at things like supporting of hoses or tubing, leaks, corrosion, material differences, things like that. We're trying to help with that kind of stuff. But we also utilize this same application service to advise on the analytical systems as well. And so before I go any further, I just wanted to go ahead and make sure that there was kind of a differentiation between online and grab sampling. So online is usually a fully automated system, right? There's a continuous monitoring of a process, whereas grab sampling is you're pulling a sample from the process and then taking it to a lab to be analyzed later. Basic rules, no matter whether you're sampling continuously or taking grab samples, you've got to be representative. You can't modify or contaminate the sample. You've got to be timely. We need to really understand a little bit about what timely means. So it's a little bit different definition for different applications and different analyzers. For instance, if a particular analyzer takes 3 minutes to analyze a sample and then has a purge cycle that's 3 more minutes or something like that, maybe it doesn't really require to be a 30-second time delay from the sample leaving the tab to getting to the analyzer. Maybe we have a little bit of leeway there. So again, just kind of defining what that means. And then compatible. Not only do we need to worry about being compatible with the equipment, but we also need to make sure that we choose a lot of components in the system that are going to be compatible with the process and vice versa. We need to make sure that the process is made to be compatible with the analyzer without modifying any of its physical or chemical properties. So to do all of that and base a lot of what we are doing as far as doing this design, we're utilizing a couple of industry experts. So Tony Waters and Phil Harris are industry experts in sampling systems. They are usually, if they are not on site with us doing these reviews and walk downs, they're helping us review the data that we've collected and help advise us on whether things that we have identified as process improvements are going to be of the highest value to you guys. We also use, Tony has written 2 books now on this particular subject. You can see the process gas chromatograph book cover. This is newest book, and this is just on process gas chromatographs. It's an entire textbook and course on there. We also utilize his process industrial sampling system book. So this is what we base all of our calculations and a lot of the time delays and best practices, things like that. They're all based on that particular book. So in any basic sampling system, we have a sample that's in a process pipe, right? That process pipe is going to have its own process conditions, pressure, temperature, flow, particulate levels, and moisture levels are definitely going to be present in a typical process. We're also going to have an analyzer that has its own particular process requirements. It can only take certain pressures, temperatures, and flows, usually not really high particulate levels, if any, usually no moisture, and we really need to make sure that it's close, but not too close to the process, right? We have some kind of constraint around that. We also have environmental conditions that we have to consider. Temperature swings are definitely going to be part of that, but is this a hazardous environment? Is this in a place where we're going to need to worry about the sun or monsoons or things like that? So we got to really consider a lot of where this is actually being installed as well. So again, the whole premise and point of grabbing this sample is to make sure that we don't change it, make sure that it gets to the analyzer in a timely fashion, and make sure that we don't damage the analyzer, because the analyzer is likely one of the most expensive components in the entire plant, right? So how do we get that sample into the analyzer? Well, the first thing that we need to do is put a process tap in. So a lot of applications that I see, there are just basically weldolets installed on the side of the process pipe where there's a threaded connection, and you screw in a MPT connection and pull a tube. That's okay for some processes, but we might want to consider how I've installed here a probe. And a sample probe is really utilized to make sure that we get a clean sample. So we're trying to avoid grabbing particulate. We're trying to ensure that we have a representative sample that may not be stuck to the side of that process pipe from a number of days or years. Doesn't have scale in it, so that we don't have to worry about filtering that out, things like that. We also want to consider adding some valving to this, maybe a single valve setup just to block the system to perform maintenance, maybe a block and bleed. It just depends on the application and how you want to handle that. But certainly at least a single block, if not a block and bleed, would be preferred, just so that you can maintain your sampling system and don't have to take the process down. However, now we've got just a process tap spraying process trying to get it into the analyzer, right? So I mentioned before, tubing it to the analyzer. So usually we're going to tube that directly to the analyzer. And again, for some processes, this is the perfect setup. We don't have to add anything to this. We're at the right pressures, temperatures, and flow rates to get to the analyzer. But for most other processes, we're not going to be able to do that. We're going to have to at least drop the pressure in most cases. So in this field station module I have drawn here, let's consider that we're sampling a gas, for instance. You want to install a regulator as close to the process tap as possible and drop that gas pressure to 1 bar. And this is going to be able to flow this is going to be able to flow your gas to the analyzer as fast as possible, right? This is going to increase your velocities. You're flowing less gas molecules, therefore increasing the velocity of the gas when you're decreasing that pressure. So this would be a typical installation in the field station. Other things might include pumps. If you're at too low of a pressure to get from point A to point B, consider the distance that you are from the process tap to the analyzer. Just any other components like that. Just again depends on the application. Next section of the system is our conditioning and maybe calibration system. We kind of combine these together because we can fit them all together in the same enclosure really close to the analyzer. Usually an analyzer isn't going to have one single stream. It's going to have multiple streams from different processes, mostly because again, I've said this before, that the analyzer is fairly expensive and has capabilities of analyzing a wider array of process conditions and physical properties of your process. So one particular process could be used across, or one particular analyzer could be used across multiple processes. So switching between those are going to be really important. We need to make sure that we don't contaminate each sample as we switch between them. We also need to make sure that we don't contaminate the calibration gas or fluid as we place that into the analyzer for the calibration mode to make sure the analyzer stays accurate. So to do that, we really try to push for a continuous flow setup, and with our SSV, our stream selection valves, we're able to really have a compact footprint and keep really low volumes and something like that. So that would be a product that would be pretty applicable for that. Sometimes our requirements are much larger than the compact footprint as stream selection valve, and we have to choose some different things, and we can get into that just depending on process conditions. Next thing I want to talk about is maybe adding a fast loop section. So maybe we're sampling a liquid in this case, and the liquid is traveling at a really high flow rate. However, we can't take that flow rate into the analyzer. Usually an analyzer is at 1 liter a minute, and to sample a fluid at 1 liter a minute all the way through the conditioning system and into the analyzer is going to produce a time delay that's maybe hours to days. So we need to combat that with increasing the flow rate all the way up to the conditioning system, and so that's where a fast loop comes into play here. We can increase the velocity of the gas or liquid and have it return back to the process, and then take a smaller amount of sample at a lower flow rate to take it to the analyzer. So at this point, we've got a pretty full system, but we have one more piece to worry about. We have to dispose of that sample. We can't just blow it out into the atmosphere. Of course, sometimes if we're sampling air or some type of inert gas, and just doing a continuous monitoring of a tank blanketing application or something like that, maybe that's fine. But in most cases, we're probably going to have to dispose of that sample, or the sample is of high value and we don't want to just throw it away. We need to do something with it. So we need to consider pressure drops through that sample disposal system. Where is that going? Do we need to find different locations in the process to be able to drop that process back into a lower pressure? And one final thing to think about is now grab sampling. So this would be placing a module likely in a fast loop so that we have a continuous flow and a really reliable sample, and being able to take that back to a lab to verify your analyzer, to make sure that your analyzer is actually calibrated correctly. This is usually a double check validation step that people employ with their online analyzers. Again, just more of a verification if you have an online system. One other thing to consider that I mentioned before, really might be worried about the environment. You might need to put a shelter around that analyzer. So is it going to need an HVAC system to keep the temperature from exceeding the limits of the analyzer, or maybe even a heater to keep it warm? Certainly a roof over it so that it protects all the electrical components. You're going to have it rated to class 1 div 1 or something like that. So covered a lot of different areas of the entire system, and that's probably a lot to think about at one time. So we've tried to break these up into smaller sections just to consider the bits and pieces. So I started with the sample extraction system before. So whatever components we require to pull that sample from the process pipe. Again, probes, valves, things like that. The field preconditioning system. So this is what we need to do either in a fast loop or a field station module, dropping the pressure, increasing the pressure, modifying flow rates, things like that we really need to help get the sample to the conditioning system. So the sample conditioning system is where we're actually going to be manipulating that sample into a way that the analyzer can handle that sample. So we're dropping pressures, dropping temperatures, changing flow rates. We're really modifying some of the physical properties of the sample without changing any of its chemical properties to be able to get it to the analyzer safely. We're also probably going to integrate into there the calibration switching system. We want to consider this separately because not all analyzers will need a calibration switching system, but if you do require one, those are probably going to be really closely connected to the conditioning system. We just need to consider how do we handle those types of systems. And then finally, the sample disposal system. I said it before. We really want to understand pressure drops, make sure that we're not putting any back pressure on the analyzer, so we have continuous flow out of the analyzer, and where do we take that sample. So these are basic conditions for either online or grab sampling. It's just easier to kind of show it in this particular setup. Any questions so far? Don't see any in the Q&A.
Yeah, we don't have any showing up, but feel free to use the Q&A feature to ask any questions you have.
All right. So moving on, I said I wanted to really kind of dig back into grab sampling and show you guys a little bit of the design systems that we have. Again, we use grab sampling as a way to describe this particular sampling method. Again, it's just our language. It's probably called something different, or could be called something different across many different plants. So sampler, lab sampler, field sampler, just the way that we're describing collecting a fluid from a pipeline or a tank or other system. And we're probably going to capture that into a cylinder or into a bottle and transport it somewhere either at the plant or across the world for analysis, right? Again, showing a little bit of a picture differentiation. We've got the grab sampling system over here, where we're actually really close to the process, turning valves and taking the cylinder off to a lab to be analyzed. Whereas the online system is in a nice shelter. It's contained, it's run by PLCs, directed back to your DCS system, giving input back to the process. So mentioned a little bit on the containers before. We can choose between a glass bottle or a cylinder. I think there's certain cases where I've seen balloons or just jars or cans to grab these samples from process taps. The great rule of thumb is, if you've got a gas or a volatile liquid, you're going to want to take that sample in a cylinder. Anything else that's non-toxic and a liquid state and isn't going to vaporize and is non-volatile can go into a glass bottle. Wanted to touch a little bit on our geared valves and then show you guys actually how they work in the system itself. So these geared valve handles that we've created and packaged in this gearbox that you see actually switches up to 3 valves to be able to switch between your inlet and outlet and vent lines without having to turn 3 different valve handles and kind of guess where to go. So like I said, I'll show you how that works here in a second, but it's just, like I said, turning 1 valve handle allows us to operate 3 valves at one time. Wanted to point out before I showed you these things that the liquid or gas is just a mirror image of itself, right? So one system, liquid, we're going to fill from the bottom up. So the inlet is actually going to travel in and up through the cylinder. It's going to allow gas to escape and make sure that we've got a clean and representative sample. Whereas gas, like I said, is going to be the mirror image of that. So we're going to come in and actually fill through the top of the cylinder, and that's going to allow condensate and debris to flush out of that cylinder, so that we've got a clean representative sample of the gas. So, I wanted to show you the geared valve handle and just how that operates. So if a customer is coming up to the panel to take their sample to send off to the lab, they're going to first come up and switch the valve handle into the sample position. So this is actually a locking handle, so you'll have to press that locking lever in, and then you're able to switch it over to sample. Notice we're coming in and switching through the vent, filling through the bottom of the sample cylinder, right? This has a dip tube, so it fills all the way up to the dip tube, and then continuously allows the sample to flow through the outlet. Again, I wanted to point out that this valve has now operated this one handle has operated these two valves. And so you see now we've opened up both of those valve ports to allow the flow to go through. Next step is to switch the valve handle to the off position. So your sample is now not flowing through anymore. And you can see we've closed off both the inlet and outlet. Now we're going to shut the valve handles off on the sample cylinder, and that's going to trap your sample in the cylinder. Now we're going to switch to vent. Now we've operated the valve to open up the flow to the vent. Notice the inlet is not flowing anymore, and the flow is now coming off of the outlet and inlet of the sample cylinder, draining the system, allowing you to remove your cylinder without any spillage or any wasted process. It's going all back to the vent. So where that vent goes is it's going to be up to us to decide as far as best practices. I'll quickly show you how this works with 3 valves being operated by one handle for the gas system. Again, same idea. We're going to come up and switch our valve to sample. Notice our 3 valves have now opened up to allow flow to go through. And now the cylinder is filling up through the top. Again, we're sampling a gas, right? Once that's full, we're going to switch the off position. Notice we've switched our handles, or our valve flows all back off. There's no flow in the system. Close our valve handles as we did before, sealing our sample in the cylinder, switching to vent, allowing all the gas to start going through the vent and opening up our flow through the outlet and into the vent. The next step is to purge. So consider this is a toxic gas and we want to purge out all the lines, maybe with some nitrogen or something like that, so that everything's clean and inert and everything's safe. So the purge flows through the entire system and then back out through the vent. And so again, that's one valve handle, either operating 2 valves or 3 valves. Just wanted to really kind of show you that and show you how these systems are set up. With these systems, you get sales drawings, you get the complete bill of material and spare parts lists. You've seen these in these pictures that I've shown you so far, a little placard. And what this has is actually the instructions for how to operate the panel. So any person on site that needs to come up and take the sample doesn't have to have a lot of formal training. Again, one valve handle to operate the whole system, just some instructions on a sequence of events. Switch it to sample, shut your valves, flush your lines. So to go with these sample cylinders, especially with gas or volatile liquid sampling, and if you're going to transport this, you might run into an instance where the sample is going to start exceeding the pressure of the sample cylinder. And there's some DOT regulations normally for how much pressure can be in that cylinder, and sometimes you even have to have what we call an expansion cylinder. So we can kind of tube this up into a really compact footprint so that this still fits into the footprint of the grab sample system. And then we can also add this relief valve to allow you to continuously capture any sample that may have released out because the overpressure has opened up the relief valve. Put a little gauge on it so that if the relief valve is actually opened up, and then to have a visual indication that you might need to deal with that. Something that is also really clever that I think we've come up with is a mounting for a full stainless steel enclosure. So there's certainly applications I mentioned before where the environment really requires you to have these panels mounted in an enclosure just to meet either a site hazardous area regulation, or because the environment is just so toxic that it starts destroying equipment over time. So traditionally those things are mounted flat on a panel. It takes up a lot of room, and they're kind of cumbersome to work on. And if we had our typical installation, we would have the panel with things mounted on the back, and you wouldn't be able to access the back of the panel to work on any of the components without pulling the entire system out. So if you mount it on a pedestal like this, instead of mounting directly onto a flat surface, you're able to now have an access panel on the back of the enclosure to really work on these cooling lines or gauges that may fail, or just things that require maintenance over time. So really small, but probably one of the most significant features of what you could add to some of these systems. So again, just to recap a lot of what we've been talking about today, we're going to really employ all these best practices into a lot of standardized designs. We're going to try to make sure that we're having a timely representative sample. We're going to try to build this all into one part number, and we're backing it all by the limited lifetime warranty at the end of the day. So that same warranty you've got for the valves and fittings that you buy is also applied to a sampling system that you purchase from us. And so on top of the site supervision and product selection that we can offer, we can then offer more engineered to order products. So these are things that are almost particular for your specific process that you need a specialized part to be designed for. And so we can certainly help with that. System identification and things like that are also part of some of these surveys that we offer as well. So again, open it up for questions, and if you think of something along the way, I've got our engineering info box ready up here, so that if you do come up with a question later and want to reach out to Ben or myself, you can shoot us a message into that.
Looks like we don't have any questions right now, but like Brian said, please feel free to put them in that Q&A section, and we'll see if we can get you some answers. Well, Brian, this is just a general question, but when you mention a fast loop, what's the primary reason I would want to use fast loop?
Yeah, we really want to use those when we've found out that our flow rates are really low. We're trying to increase our time, well, not increase, decrease our time to the analyzer when we're trying to employ those fast loops. A lot of times we can kind of kill two birds with one stone with something like that. utilizing like a third-party product like a swirl clean filter or something. Those usually require higher flow rates to be able to remove particulate out of a sample. And again, we're trying to reduce that that time to get to the analyzer. So if we can filter and increase the velocity of the sample, that's going to really help us out. And so I've seen where we can change a time delay from a few minutes to less than a minute with just employing a quick fast loop, something like that. I can't believe that I've answered all of the questions about sampling systems in 40 minutes.
It's just so thorough.
Yeah, I touched a little bit on probes and things like that, and we'll mention that we do have some calculators for choosing and selecting a probe, and we've also got a couple of different options for probes and retractable probes and things like that. So you have a full kit. So if you got a question about how long of a probe do I need, and it needs to adhere to an ASME specification or something like that, then we can definitely help you out with sizing that probe appropriately for what you've got.
Looks like we got one more. It says, can awesome. We incorporate third-party products into sampling system designs?
Absolutely, we can. Yeah, we've done all the way from I think I mentioned before, this like a swirl clean, a filter that just isn't something that we offer. It's a particular thing that is manufactured by certain companies, all the way through to we've integrated pumps and even a full shelter in before at some sites. So we can certainly support third-party products and have kind of a turnkey solution for you if that's what you're looking for.
Sure, and that sometimes comes with like coolers and those kind of things where we have
to absolutely
beforehand.
So. Sample cooler is definitely something we've added in before, and we can certainly help with working with you and the manufacturer to find out the size and what temperature we can expect out of that sample cooler. Yeah.
We'll give another minute or so just in case somebody wants to chime in, but
absolutely.
Also, if you were with us on the process interface valves, obviously those are maybe your first step to connecting to your analyzer system as well. And you kind of briefly touched on that, but.
Absolutely. If you decide you didn't want to go with a probe for whatever reason, I would still suggest you use at least the double block and bleed or the block and bleed process interface valve. Yeah, that'd be a great step.
All right. Well, again, thank you for joining us for the analytical instrumentation webinar that we've provided. Feel free to reach out to us at that engineering@georgia.swagelok.solutions at any time. You'll actually get Brian, myself, possibly one or two of our other engineers here at the Swagelok, Georgia, Jacksonville, and South Carolina offices. So